Another type of network connectivity that we're frequently using in today's networks is, of course, wireless connectivity. And it's probably used as prevalently with Windows 10 as a wired connection, especially depending on the scenario, depending on the device. And so as technicians, we really need to be aware of the capabilities of various wireless protocols, of the inherent dangers of wireless connectivity in relation to security, and how we go about handling that. And then, of course, how Windows 10 specifically deals with wireless communications and how you configure wireless connections. So, just to start, we can make a statement that wireless connectivity is really any networking style where the devices are not using cables. They're using some form of wireless technology. So that does include Wi-Fi and Bluetooth and infrared. And of course there's various types of Wi-Fi. Usually when we're talking about wireless connectivity in the context of a computer, we are speaking about Wi-Fi, but it's possible that we could be talking about Bluetooth as well. So just in general, that's wireless connectivity. The benefits, of course, to wireless connectivity are that you get mobility. You don't have to extend wires. You can run a computer and get an internet connection or access to a file server or a printer in places that you wouldn't normally be able to do that. Okay? Whether it's a warehouse, a conference room, a living room of a home, the front portion, the lobby portion of a small business. Those are places where wireless connectivity can go and wired connectivity would not be able to happen. And so thus, if users are more mobile in a business sense, it helps us to increase in productivity. If you've got a mobile device, a tablet or a laptop, you can carry it around with you and you can keep working wherever you're at, then obviously that's an increase in productivity. And then an access in public places, so most businesses will provide some form of Wi-Fi connectivity to allow visitors to access the internet. But there are some disadvantages as well. One of the disadvantages is interference. We don't have this issue really with Ethernet cabling, but with Wi-Fi, we're using radio frequencies. Those radio frequencies are within a spectrum that is shared by other devices. Power equipment can cause interference. Microwaves, cellular phones, or cordless phones, I should say. Those can cause interference with Wi-Fi as well. And the materials of a building can cause interference and a problem. Some buildings' Wi-Fi signals can go a much shorter distance than they could in other places. So you always have that, and you have an inherent decrease in security. I mean, with a wired network, you at least have to find a port that's live and plug in. With a wireless network, you can sit out in the parking lot of an organization and you can get connected to their network. You just have to be within range of the signal, and you have to have your wireless network card tuned into the right signal. You have to have the password, potentially to get on to the access point, but even those are sometimes discernible through the use of software. And so there is an inherent lack of security or just less security with Wi-Fi. And to account for that, of course, we have all manner of different Wi-Fi security protocols that we'll be using. There are two basic categories of Wi-Fi types of networks. Those are ad hoc and infrastructure. Now, an ad hoc network is a point-to-point type of network that is between two systems without the use of an access point. This isn't overly common, at least not in a business sense, but it is becoming more and more common on the device level. It's using technologies known as Wi-Fi Direct, which is a technology that has been increasing in the later years. Windows 10 definitely has a beefed up version of Wi-Fi Direct. Wi-Fi Direct, it simply allows point-to-point connectivity between two devices via Wi-Fi. But it's often used, and the API that's in Windows 10 is used in conjunction with applications. So for instance, just the one for instance that I have comes to mind immediately is the ability to synchronize photos from my phone. from my phone to my laptop, specifically to a certain program on my laptop that is using Wi-Fi Direct. So it sets itself up as a little mini, it looks like an access point to my phone, or it looks like a wireless network to my phone. The phone connects, and then it imports photos as soon as it gets within range, so long as the Wi-Fi is turned on the phone. So that is Wi-Fi Direct. It is often used to transfer from mobile devices to an application on the PC, although it could be used to communicate directly between two PCs to, say, share media libraries or something like that. All right? So an ad hoc network, they're becoming a little bit more common just for individual file sharing activities. But infrastructure is what we run into when we are in a computer network. When we're on a business, or we're in a business and we're talking about their wireless network, and when we're in a home and we're talking about the wireless network, it's an infrastructure mode. And the reason we know that is because you're getting an internet connection. I mean, ad hoc connections just are point to point between two systems. You don't get out to the internet. So as soon as you are getting out to the internet, then that's infrastructure mode, because you're connected to a wireless access point that's connected to a physical cable. At a home, maybe it's connected to a cable DSL modem. At a business, it might be connected to some other type of connection, as well as the standard Ethernet on the, at the business. But the point is you're connecting through access points. So from a business sense, that is far more likely than the ad hoc networks. Windows 10 supports all the latest protocols in the area of wireless connectivity, the latest connection options and such. They have grown every couple of years. It seems we get a new version, a new protocol. 802.11b was one of the originals. It was going to allow transfer speeds up to 11 megabits per second. It operated on the 2.4 gigahertz frequency range. It is pretty much obsolete. I mean, you can run into some older equipment that uses 802.11b, but that equipment really should be replaced at least with 802.11g, which was the successor to 802.11b and backward compatible with it, up to 54 megabits per second transfer rates, but also operating on that 2.4 gigahertz frequency range. The one problem there is those are a little bit more subject to interference because that's a very crowded frequency range. They had developed 802.11a because of that. It was also up to 54 megabits per second, but it was operating up in the 5 gigahertz range, which was just a less crowded range. So it worked better in more densely populated areas. It was capable of using up to 8 non-overlapping channels. So the wireless is on a particular frequency, but then it also operates on a channel. And so if you've got multiple access points and they're operating on the same channel, then you can get interference that way. Well, so having 8 non-overlapping channels, helped the access points to negotiate a channel when they were initially getting set up, and that's how it worked better in a more densely populated area. Having said that, 802.11a didn't really ever pick up. It was too expensive. It was not included on the wireless NICs. You very rarely would see a NIC that was only 802.11a. It would always be a combo card with B and G. No access points that I've ever seen would be 802.11a, and so it's just kind of fallen off by the wayside. 802.11n was the next replacement for 802.11g, up to 200 megabits per second with speed burst technologies, which are known as MIMO, multi-input, multi-output. You could conceivably get up to about 600 megabits per second with 802.11n. That really is the current standard. I mean, it's the most common one that you're going to see now if you're purchasing wireless equipment would be 802.11n. There is a newer one, but it hasn't become quite as common just yet, and that's 802.11ac. And that is a version of wireless that's going to be well up and possibly even in excess of a gigabit per second for wireless connectivity. So that's kind of, it is out, it's standardized, it's up and coming, but Windows 10 will support any and all of these connection options. As we said, with wireless, you have an inherent security risk due to the open nature of the technology, and so we have to have these additional security protocols in order to account for that. Windows 10 supports all of the same security protocols in the area of wireless connectivity that were supported in the previous versions. At first is 802.11. 802.11 is technically an open system, or can be, an open system, or can use shared key authentication. And it uses WEP for encryption. So WEP is Wired Equivalency Protocol. That is a much older, the original wireless security protocol. It is very much insecure. It is fairly easy with the right software to crack WEP keys in a matter of minutes. And many security professionals will tell you that it is essentially no good. I mean, it's essentially not much better than having nothing at all. I don't go to that extent because your common everyday user can't hack a WEP key. But if somebody knows at all what they're doing, they will be able to, and they'll be able to quickly. So, I mean, we always have an alternative. We're never going to use 802.11 as our authentication and set up shared key with WEP for encryption. It's just not going to happen. Businesses are going to choose between 802.1x and then the Wi-Fi protected access. So 802.1x uses a protocol called EAP for authentication. That's Extensible Authentication Protocol. It allows the client and server to negotiate what level of security they're going to be using. And EAP can use username and password-based authentication of the user, or it can use certificate-based authentication. So you get into a business setting that's using 802.1x, a lot of times what we have is a computer certificate that's installed on the laptop running Windows 10, and that computer certificate authenticates the computer to the access point in a very secure method. Now, they're still using WEP for encryption with 802.1x, and so it doesn't have the strongest encryption if you use that mechanism. But what we'll see is with Wi-Fi protected access, you actually have a combination of the two. Now, this is standardized as 802.11i and has two modes, a personal and enterprise. It also has two versions, WPA and WPA2. So WPA2, of course, would be the most recent, although it's been out for many, many years. And that's the one that we should be using. Personal mode, we'll use passphrases. Okay? Passphrase protects the key, and those keys are protected either through TKIP in version 1 or the advanced encryption standard in version 2, which is much stronger. Those keys, unlike the WEP keys, are constantly changing. The passphrase gives you access to the key. So we want a secure passphrase, and then we really have a secure network. With enterprise, it's going to be a combination of 802.1x and WPA or an NAES for encryption. Okay, so you take care of the WEP for encryption by doing that. So you would be using something like certificate authentication of a computer account in order to get access to the Wi-Fi network, but at the same time you would be encrypting communications with AES. Okay, so WPA2 Enterprise most certainly going to be your most secure option for security protocols in Windows 10 on a business network. There are some additional things that we can do to secure wireless networks that you might find being done or have to interact with. One is network segmentation. So sometimes wireless networks are segmented off of the main business network and just used to provide internet access. That's fairly frequent. Or you might have two separate wireless networks. So one is for guest and for internet access, and the other is for business reasons. That segmentation often happens via firewalls. The firewalls then control what can flow between the wireless network and the wired network. Okay? Might even still be using the same subnet, but there is some control as to what type of information is shared between them. Sometimes wireless access points have MAC filters set up. A MAC filter is based on the media access control address, the physical address of your network card, and it's a way of enabling or disabling access based on a particular client. So in high security networks, sometimes there's a list that's built of the MAC addresses of the clients that we want to connect. And then if you're not on that list, then you can't connect. Alternatively, we could have a deny list that included MAC addresses. Well, you can see how if your organization's doing that, we would need to know that because a change would have to be made in order for us to connect a Windows 10 client to the wireless network. It's also possible that an organization is disabling the broadcast of your SSIDs, your service set identifiers that identify the wireless network by name. If that is not broadcast, it just shows up as an unnamed network in Windows 10, and the user making the connection would actually have to know the name of the SSID in order to connect. Okay? Normally it's broadcasting by default, but sometimes people do turn that off for security reasons. That means you have to take an extra step to get connected to it. Essentially, there are two required components if you want to connect to a wireless network. The first is the wireless network card or wireless NIC on the machine. In a laptop and a tablet, these are embedded and they are there by default. Same thing with a phone. On a desktop computer, they don't generally include wireless network cards. You would have to install one. They come in the form of internal cards, or you can even have wireless cards that plug in via USB. But you need that because it's got the antenna on it. It's capable of then communicating on a particular radio frequency using a particular standard. Some of them will be backward compatible. So 802.11n, for instance, is backward compatible with G and B. You're always going to be operating at the speed of the slowest component. And then we also need a wireless access point. Now, I suppose you could say, well, you don't need that for ad hoc, and that's true. But for infrastructure type of connections, you're going to need a wireless access point. And that wireless access point has an SSID configured. And this is part of what you need to know in order to connect. So you can see when I get into my network and internet settings in the settings app, I have a Wi-Fi settings area there, and it's going to list out the networks that are in close proximity to me. It'll show me the network I'm connected to, or I can select one of those networks and say that I want to connect to it. Okay? Now in this case, it's a screenshot from a laptop, and it's automatically connected to a network. And just like previous versions, when you connect to a network for the first time, you can choose the checkbox that says connect automatically. Okay, and if you do that, then it will connect every time it identifies that network. There are various methods that you can use to connect. The network icon down in the system tray, like previous versions, will show the wireless networks that you potentially could connect to. And then you have the network and internet settings in the settings app. And then you could use group policy configuration. There are wireless profiles that can be configured for domain clients inside group policy. Primarily, you need to know the SSID, but then you also need to know security information. You don't need to know really what protocol is being used, but you need to know the passphrase, or the WEP key, or if it is actually using 802.1x and certificate authentication, then that's a little bit more extreme, and at that point, we're going to have to make sure that we have certificates. So you have to know how you're going to be connecting, what type of information is going to be required. Another option there in the settings app was a link to manage Wi-Fi settings, and some of these are new to Windows 10. So when you click manage Wi-Fi settings, you get this screenshot that we see here, and it's actually configuring automatic connections. And it's asking, do you want to connect to suggested open hotspots? Do you want to connect to networks that are shared by contacts? And then as you can see, you can choose which types of contacts you're going to be working with. You can even give it access to your Facebook account. So this is referred to as Wi-Fi Sense, and this is a new feature in Windows 10. It allows you to share networks with contacts, and the key is that you can share networks with them, and they can share networks that they know about with you, and they don't need to know the password. okay? So if this was, at my home or something, then I could turn on Wi-Fi Sense or leave it turned on. Anybody within close proximity to me could see that network and connect because I've shared it with them without having to be told the password for my wireless network, okay? This is one of these features that I kind of look at and it's a little bit, okay, that sounds nice. I'm not sure how overly useful it is, but this is Wi-Fi Sense and it's a new feature. If you click on advanced options back on the main page, you have access to a couple of other settings. Those are the find devices and content, where you can choose, on this network that I'm currently connected to, do I want to do, a network discovery? I mean, that's basically what it is. It's just a little on-off switch, like what we see in this screenshot, as to, doing the network discovery or not. And then you also have another on-off switch for a metered connection. Okay, the metered connection is if you're on a data connection, and you want to slow things down and you want to control the amount of bandwidth that's sending over that connection, then you can turn it on. So when you connect to particular wireless networks, you can turn on and off network discovery. You can turn on and off the metering, and then also you have the ability to share. So some new features, some new screens that you would not necessarily recognize because they weren't in previous versions. If you got a Windows 10 machine and it's a laptop or it has a wireless network card, I'd get into the settings app and jump around in there and play around. One of the problems here, and the reason we just use screenshots, is because if you don't have a wireless network card, Windows detects that, and the Wi-Fi settings just don't exist. It's nice that they don't muddy the waters, I suppose, with a bunch of settings that are irrelevant to you. But from a demonstration perspective, it would sure be nice if the stuff was actually still there. But much like the power options for a laptop have always been, if you're not on a laptop, if you don't have wireless, then those options don't appear. So most of you will be able to get on a machine that has that and go look around at some of these unique settings on Windows 10.